Hello. Hello, everyone.
Hi.
I am Jagjit Full. I'm going to be your trainer for these sessions. So, how many participants are there right now? Seven, I guess, right? Logged on.
Yes, I think including you, probably.
All right, okay. Till everybody else falls in. Uh, Let me just give a little bit of introduction of myself. I have around 27 years of IT experience, worked through various organizations throughout my tenure, and working with Linux since 1994, uh, and worked with organizations like IBM, GE, HP, and all. So throughout my career, Linux has been quite. I've seen the growth of it happening. Then a lot of trainings being conducted. I do a lot of consulting for the projects based out of Linux. So that should be sufficient for me from my side. Okay, so I would like you all to put up about your experience. How is it? How was the last training, and what all things did you learn, and what is the expectation from this training? Okay, so starting with Andre. Andre, could you just give briefs about your experience, summarize how has it been your experience in Linux, and what is the expectation from this training?
So my name is Andre. I'm a storage storage admin with NTT. I never worked with Linux per se as an admin, but I've dabbled with it on and off during the years. So I have some basic experience and just looking to further my knowledge into Linux.
Okay, great. Thanks, Andre. Okay, so next I guess is if my pronunciations goes bad, please don't mind. Guillermo, right? Should I pronounce it that way? Guillen or Guillermo?
Yeah, you can just say Guillermo. It's okay. It's
Guillermo.
in
Okay,
Spanish it's
fine.
Guillermo, Guillen, but it's a bit difficult for everybody to mention that.
Okay.
Okay, I've been on the Unix Linux world practically as long as you. I've managed Solaris. I started with FreeBSD, Slackware. I have managed also IRIX from Silicon Graphics. AIX from IBM, a bit of HPUX. Linux, of course, Red Hat have been managing that for a few years. My expectations for this training is actually to see the what differences, what new features Red Hat 8 has, especially in comparison with the Red Hat 6 and 7. So that's pretty much the expectations I have for this training.
Great, great. This is awesome experience. It's really fantastic to know someone as antique as me working with this very. So great. Thanks. Okay. Next is Javier, right? Should I pronounce it that way, Javier, or how is it pronounced?
Yes, it's pronounced Javier, but yeah, it's fine. Javier.
Javier. Yeah, I know it's J to be called as something like hey, right? That's
Yes,
how it is.
no problem.
All right. Yeah. So Javier, right?
Yes, it's okay. So I'm from the Windows sysadmin, and I mean I've been working on for that. So I just finished the Red Hat 8 training 1. So
Okay.
I'm just new to this. It's been a long time. I don't use it. I used it when I was in college, which has been a long time, but
Okay.
not really involved on Linux administration in the last year. So that's why I'm taking this as
Okay, so
a
you've already
refresh.
done SA1 training, right? How was
Yeah,
your experience on that front? How did
it
you
w-
feel about it?
it was really good. I mean, I everything was new. I remember a few things, but it was very new for me. So everything was good and well, like I'm learning like a new technology right now, so everything is new, and my
Well,
expectations are well just to continue in the same path that I guess it's gonna be a little bit more advanced, obviously, but well, we'll try to do and keep up with labs and all that.
great. Okay, sure thing. Thanks. Okay, next is Sridhar Murugan.
Hi, this is Sridhar Morgan. Basically, I'm a AX administrator and also database administration. I'm into database administration. Sorry, data center administration.
Okay,
Um, yeah. So I'm not sure about pretty much in RHEL. So I need to learn more on RHEL. So I have completed my Red Hat administration training 1 in last week. So this is training 2. um, I'm looking into for the troubleshooting and monitoring in deep level. I'm expecting in this training. So
okay.
yeah.
All right. Okay. So any prior experience in Rail, or this is the first SA1 just completed and
And
that's it
yeah,
to be?
this is the first training in Linux. Previously, I was working in, I told you know, AX and virtual IO on IBM product level.
Okay. AX, which version have you worked with?
I worked in 6 and 7.
6 and 7. All right. More compatible towards Linux kind, so shouldn't be much problem. Okay, great. Thanks, Sridhar.
Yeah.
Okay, then we have some code 125205. May I know who is it?
Hi, my name is Jay Kumar. I am into Unix administration with NTT. So
Okay.
basically, I have around 15 plus years of experience. Basically, I'm an AX guy where I do handle all versions of AX, including LPAR, VIOs, VMs.
Okay.
So apart from that, I'm having experience in Red Hat for around 6 to 7 years of experience. And basically, I didn't attend the training one because I was on vacation. So I'm
Okay.
just attending this session. I expect there should be some new features in Red Hat 8 which I could explore and serve my clients.
Sure. So Jai Kumar. Okay, thanks for sharing. Next is Neeraj Rajpal.
Yes, I am Neeraj Rajpal. I have around 20 years of experience. I'm from Windows admin background. I worked on Linux around 15 years ago. I did essay training 1. It was refreshing the old stuff
All the concept.
and
Yeah.
working on it. I I plan to work in Linux environment now. So I'm looking into learning, monitoring, and troubleshooting, and some advanced stuff because in my current role, I'm also managing Linux servers. Most of these are Red Hat only. So
Okay.
that's my expectation and requirement.
So do you all have to manage Red Hat version older, like 5, 6, or it's all
Yes.
upgraded to 7 and now being planned for 8?
No, up till now, up till 7.0, we have all versions, various versions of
Okay, so
Linux.
upgraded till up till, okay, great, 7. All right. So expectation from this training, Neeraj?
Is troubleshooting and monitoring because
Okay,
that is our operational work that we need to do.
cool. Okay, so we'll keep that in mind and proceed accordingly. That's really fantastic. We'll be talking about a lot of areas, new features which have been coming up with 7 onwards. Okay, cool. So next is Vinod. Is Vinod there?
Yeah, hi. Can you hear me?
Yeah, I can hear you. Yeah, Vinod.
Yeah, hi. So I manage the field tech support for entity. So I have a team that manages the multiple infrastructure support for multiple clients.
Okay.
So I don't have any work experience in Linux, but whatever knowledge I have is self-taught. I have learned myself. So the whole idea of joining this team is I can learn more about Linux, so that so it's easy for me to support our clients much better, because more and more clients are getting into a Linux platform, and I think this training will be helpful to learn more and be more supportive and help our
Great.
clients.
Yeah, it's Linux is a trend today. We can say everywhere you see Linux getting into. Right. Okay. So I see a code 119596. May I know who is it?
Hello, this is Samna.
Yeah, Sam. Yeah.
I'm from the network tools team. We basically manage applications for network infrastructure, and this is running on 6. And as I've been as Unix admin for Solaris and Linux.
Okay.
May
So you already
to get to
familiar
know
Sam?
the current version, the
New
one.
features and differences.
Yes, that's right.
Okay. Okay, Samna. Thank you so much. Okay. Next we have Sandeep Sharma. Sandeep.
Hi. Uh, I have a total year of experience, 12 years. I start working with Windows, and
Okay.
I'm working on VMware environment. So I just need a basic understanding of Linux commands. So that is my main purpose of joining this training.
Okay. Did you attend the SA1 training?
Yes, I attended that.
Okay. How did it go basically?
Yes, as per me, it's a very good training. It's very explanatory training.
Uh-huh.
It's very nice training, as per me.
Okay. So what all things did you learn basically in SA1?
And SA1 means actually I started using the VI editor and all those stuff, and for some commands also I learned that also.
Okay.
There's still a lot of things I need to do.
Okay, sure. So hope this next days and this day will be able to work out a lot of things. Great, thanks, Sandeep. Okay, next we come to Sunil Kumar. Sunil Kumar. Hello, is Sunil Kumar there? All right, Eduardo Nazrin, right? Nazrin, right? Is this how it is pronounced? Eduardo?
Yes, good morning.
Good
Yeah,
morning.
I'm part of the Unix team and for WK account, and I do mostly monitoring, but I do support Linux as well. So that's why I'm, taking this course, this training.
Okay, so you're already having the background of Unix, right? That is
Yeah.
what you said. Okay, cool. Which version of Unix did you work with?
7.
Okay, Linux 7. Okay. All right, expectation from this training?
Well, I think I will improve my knowledge, and also if there are new features and there are 8 version, well, that's what I expect, because probably we will upgrade some of the server or in the future, near future.
All right, okay, great. Thanks. Then next we have Catalin. Catalin.
Hi all. Thank you. I was on mute. So my expectations are very clear. So myself, I would like to improve my knowledge with Red Hat Enterprise Linux 8. That's correct. Is it the version 8 you're going to present us?
Yes, that is the version we are going to be.
So, why not preparing for certification Red Hat Enterprise Linux Engineer certification? And overall speaking, I noticed how there are some significant improvements, and also on security. I would emphasize more the security aspects, because more and more security is, let's say, top subjects on customers' concerns, and obviously we need to address and respond to such concerns. Thank you.
Okay, great. Okay, next we have Sunil Kumar come in. Hi, Sunil, are you there? All right. Next we have Paul Hernandez. Paul, are you there?
Can you hear me now?
Yeah, Paul. Is this Paul?
Yes, this is Paul Hernandez.
Paul. Yeah, Paul. Yeah, we can hear you.
So the question is the reason that we are taking the course, right?
Yes. So I would like you to understand from your side. You attended the one training also, right? Possibly
yes.
You would have. Okay. So related with that, what is the expectation? I just want to set up that all areas. So that is why just an introduction kind. That's for it. Okay. So
yeah.
Go ahead and share your experience and expectations.
Yeah, I'm part of a team that supports. I'm part of a team that supports Linux and Unix environment servers, and this is more like a refresher for me. So perhaps a reminder about the different things that we can do with the Linux, Red Hat to be specifically. So this is more like a refresher for me.
Okay, so you're already familiar with the Linux environment, right? You have worked with it prior to this trainings, right?
Exactly, yes.
Okay, cool. So how many, I think there are 14 people, right now? Okay, 14 people as I see. Any more people to join in? Anyone and has got any idea? All right, okay. So let's go ahead and begin the thing. All right, so, okay, so since you all have all kind of having experience and some are quite from Windows background, so to begin with, I would like to understand from your side, what is the license? What is the license we use for Linux, or to be rightly called as GNU/Linux? Can someone tell me? Yep. Which is the license we use for Linux?
That will be
open
the
source.
GPL.
Sorry, who said?
I was saying the GPL, the General Public License.
Okay, who did answer this? Please
This
specify.
is Guillermo.
Okay.
This is Guillermo.
Okay, so it's a GNU GPL license, GNU's General Public License. Okay, any highlights other than Guillermo? Anyone can else answer this? What is the advantage, or what are the what this license is basically talking about?
This is Jay Kumar. It is basically open source code where everyone can programmers can use.
Okay, open source. Okay, that's a very cool term. So, talking about open source, can someone elaborate on open source? Yeah, Paul, can you elaborate on open source?
Sorry, I was on mute again. So
Okay.
the
Yeah.
open
I
source,
will, sorry. Go ahead.
open source license. Well, it's a license that allows you to use a software for free, also to modify the software, and and that's it. So
All right. Okay. All right, Sandeep, what's your opinion on open source? Sandeep, are you there?
Open source means it's not proprietary to any organization, and everyone is open to put their own ideas in it.
Okay, cool. Javier, what's your opinion? Javier, are you there?
Yeah, sorry, I was on mute. It's basically that the code it's open. You can modify it. It's not proprietary of anyone, so you can change it.
All right. Okay, so let's have more understanding on that. Okay, so let's go ahead and I'll just share my screen. So I hope it's visible to everyone.
Yes, it's visible.
Okay, now this is the website gnu.org, basically what you see, and something called as Free Software Foundation, FSF, Free Software Foundation. Now, the growth of Linux has happened due to this license. Okay, the licensing terms, basically, here's the idea. What is free software? Now, when we talk about proprietary software, when we talk about open source or free software, all right, there are different opinions which I always get, where when we talk about free software, this term has been rarely used by people, very rare to someone uttering these words like free software, because the word free is causing people to understand that everything is free of cost. Okay, so they consider everything free as in regards to the money, okay, or the dollar price or the currency price. Then we always have the term called proprietary software, like you have MS Windows. Windows is a proprietary software where you have been given no liberty. Okay, you don't have the source code of it, you can't modify it, you cannot distribute or redistribute it, that kind of things. So it's a proprietary bundle, someone takes care of it, and they manage it, they develop it, and give you the executable binaries to go through all that. Okay, so then we have the term open source. Generally, when we talk about open source, Linux will be always, that is a more buzzword which people use in the industry, open source rather than free software. The reason being, as I said, free word causes a lot of confusion in regards to whether the software is free of cost. Okay, but that is not the question here. The question is about the freedom. Okay, so when we talk about free software, it is about the freedom. The freedom what we talk about here is the first one, the freedom to run the program as you wish for any purpose. Okay, so that means if I use Linux or any GNU GPL software with that license, I have the freedom to run the program as I wish, and that too for any purpose. So that is why you see Google is Google, Amazon, Facebook, Twitter, all of this, the most landmark and most famous popular websites have to be running most possibly on Linux, one of the distributions. Okay, so the freedom So if you also notice, 95% of the supercomputers also use Linux versions. Can anyone tell me which is the fastest supercomputer? Who is the current owner of the fastest supercomputer in the world? Anyone can take a guess? Yes, I'm waiting.
It changes really. There's always a competition about it, but I think the last news I heard about it was a Summit. I think it was called.
Yeah, I mean to say, which country did it belong to?
That I don't remember.
Okay, it's
Yeah.
US currently, I should say. Okay, but last 3 years, 2015, 2014, 15, 16, 17 around, it was China. Okay, so China was taking the lead in supercomputers, and the operating system which it was using was based out of Linux, which is called Chilean Linux or Kylin Linux, you can call it. Okay, KYLIN, something like that. So that was the customized Linux kernel, customized in the format to be used on supercomputers. So that ways, it's giving you the freedom to use for any purpose. So no one is going to come and question you, okay, why you're using. Like if, for example, we start using Windows, trying to modify it, Microsoft will definitely sue us on that front. That you are not supposed to modify. That means you have hacked the source code or somewhere. So that doesn't belong to you. The intellectual property, the patenting and everything is owned by Microsoft in regards to Windows. So you cannot use Windows for any purpose. If it's coming for a laptop, desktop or something, you cannot modify or change it to go for supercomputers or for an embedded system. Okay. So the very first freedom in the free software license, that is GNU GPL license, is talking about this freedom. The second freedom, it says how to study the program, how the program works and change it. So as I want to make it do the computing, now precondition is this, you should have the source code of it. Now, if you're working with the Linux, then obviously Linux kernel has been written in which language? Can someone tell me which programming language has it been written?
It's C language.
Yes,
Yeah, I see.
it's C language. So Linus Torvald, the guy who wrote this, the kernel, used C. C is the most profound and the depth knowledge. It's really wonderful. A lot of discipline is required though to code it in that. One of the most difficult language to master, I should say.
Yeah.
So the source code of Linux kernel, which is available at kernel.org. I hope my screen is visible. You can see
Yes.
Linux kernel website here. So current version is 4.5.4 RC8. That is what we call it. RC8 is basically talking about release candidate.
Yeah.
So RC stands for release candidate. So that means it's under development. So current Linux kernel version is this one, and the stable version, as you see on the screen, is 5.3.11. And long-term support, LTS we call it, long-term support, are these various versions which you are. So you could go ahead, download the kernel from here. It's pure C code. You can start coding into it after following how the whole this environment or the team works. More than 8,000 developers contributing the code into Linux kernel. Okay, and daily people keep on pouring in. Some people write the documentation part, some improve upon some areas. So device drivers, modules. So a lot of updates keep on happening. And the orchestration is done by Linus Torvald. He is the final, has the say to that, okay, this is the release which we are going to release in the market today. And the lot of distributions like Red Hat or Ubuntu or Debian or Mandriva, or you talk about SUSE, they basically go ahead, customize this kernel for suiting to their distributions, and then roll out their versions of the the distro like Linux Mint, Ubuntu, Kali Linux, so on and so forth. So everywhere you will see different versions of Linux kernel being used, choosing out of this area. So you're also free to create your own distributions if you want to bundle it up with some packaged software which you feel okay. Like for example, Kali Linux is more suited for hacking like platforms. So all the security tools, hacking tools have been built into that. Similarly, we have CentOS, which is community enterprise operating system. CentOS, we call it. It is a sibling of Red Hat, Red Hat Enterprise Linux, we can call it. So Fedora is another initiative where a lot of bleeding edge, we call it, where it is always on the verge of updates. So you never use it in the production. It is always in the kind of beta stage only. So coming back, the third freedom basically is the redistribution. And this is basically how Linux has been growing. Like if you see initially when Linux came into picture, okay, can someone tell me which year Linux is the birth time, I should say? Anybody?
1950.
Okay, Guillermo should have the answer. Yes, Guillermo.
Sorry, what was the question? I could.
Yeah, when did Linux come into being?
The disconnection because I can't.
Okay, what happened?
Can you hear me?
Yeah, I can hear. We can hear you.
Yeah, it's like my internet connections again, but I couldn't hear most of it. Question was what the Linux.
Yeah, when did Linux come into being? Linux come into being, meaning when did it? When did Linus Torvald create it?
Oh, 1991, I think.
Yes, you are right. 1991. Okay, and the whole reason why Linus Torvald wanted to create it, or he created due to what reason? Okay.
It was like a school project for him.
Yeah, kind of, you can say. Actually, going forward for he had a 386 based machine, okay, and 386 based microprocessor, I should say. So he was looking out for Linux, Unix kind of operating system for his 386 machine on Intel platform, and unfortunately, nothing was available. So he went to one person. You all must be familiar with his name, called as Andrew Tannenbaum.
Yep.
Heard his name?
Yeah.
Right.
He has a great book on operating systems.
Correct. Operating system, networking, basically. So he conducts a lot of PhD. He's a professor. So that professor has written one operating system called Minix. Anybody heard this name before?
Yeah, Minix.
Minix. So that is released under BSD license, Berkeley Software Distribution License. So Linus Torvald, approached him and asked him, okay, can we, go it and improve it and use it for production? So let's go it and brighten it. So Andrew Tannenbaum refused that, and he said, no, this is only for research project. So nothing sort of that we want. Okay. So Torvald was left out with nothing, and he, in a 6 months, wrote one kernel. Now, during that time, you can understand in 1991 around how many Unix books, available in the market. How many books would you guess will be available in the market? Hardly any. There is only one book which is called Design of Unix Operating System. So Linus Torvald picked up that book, or studied that, because that book is talking about the design of Unix. It's by Maurice J. Batch, or Back, you call it. That is the author. He's the author, and Linus Torvald, in 6 months' time, he wrote one kernel and released it to the public. But license wasn't clear, as you see, GNU GPL license or nothing. He just released it and kept it online, so someone would download, give his, use it, and give the reviews, feedback. None came forward. Then he realized that there is, since people are not clear. So again, he released that under GNU GPL license, because GNU and Free Software Foundation was, came into being around 1984, 1983, 84 on. So he used the GNU GPL license to release the software. People got the idea, people started implementing, and today we see Linux kernel has grown. So you talk about any website, any startup, or any new popular websites coming into the world, they are all using some form of Linux. And because of the freedom which it's showing here, giving here, this license. So Linus Torvald in 1991 gave forward, and then since 1992 onwards, we had Red Hat coming into being. Then Debian came into being. So these are the two major leagues, I should say. Okay, these are the two major leagues where all the distributions come forward. So either people derive from Red Hat. Okay, I'm talking about original Red Hat, not Red Hat Enterprise Linux. Okay, this is the time I'm talking about where there was no Red Hat Enterprise Linux in picture at all. Okay, so it was called as Red Hat Linux, and it came, CDs were given, floppies were given. So people used it, tried it. Similarly, it went for Debian. Then today we see Debian, based upon Debian, we have Ubuntu coming in, Ubuntu servers, Ubuntu desktop. Then further folks we have out of like called as Linux Mint, Kali Linux, and so on, Deep in Linux, beautifying the graphical user interfaces and all improvements daily. Red Hat is slightly, coming by down. 2000 and 2003, we had Red Hat Enterprise Linux coming into picture because of the Red Hat initial public offering, becoming a public company. So they had that Red Hat as a brand coming in. So RHEL came out, and then it started with all that different versions, and now we have Red Hat Enterprise Linux 8 in the picture. Okay, but the main aspect is basically talking about so many distribution is possible for the reason that GNU GPL software is giving this third freedom, redistribute copies so you can help others. Okay, in proprietary system, we don't have such thing. Okay, so Microsoft doesn't do that kind of stuff, or Adobe or IBM, they have their AIX operating system, or you call it HPUX from HP or IRIX from Silicon Graphics. You talk about it and they are not supposed to be, redistributed. But here we have a very much on a social movement kind of license, where it doesn't talk about money, it talks about the freedom. Then final freedom we have is freedom to distribute copies of modified versions to others. Okay, so that is why you have different variations like Ubuntu. So some is based on Mate, some is based on XFCE, LXD. So different graphical interfaces, people package it and give it out of, become download. And all these efforts are running through crowdsourcing, crowdfunding. Okay, so it's like people donate it and the projects are going ahead, right? So this is basically the licensing, which talks about these four things, and we term it as free software. But as I said, free word is really causing confusion in a lot of people. So that is why a more popular term has come forward called as open source. All right. So whenever you are working with the, open source software, so you have to really understand that what kind of license are we talking about. Now there is an open source license also. Okay. So there is one free software license, which is called as GNU GPL. Then there is an open source license, and there are some BSD license, you have MIT license, you have Apache license. Okay, now can someone give me any idea that what is the difference between this GNU GPL license and BSD, MIT or Apache license? Yes, anyone? We hardly think of licensing though, but I just wanted to clarify that in the industry, when you work at a level, right? So when we grow in a hierarchy in our organizations, you will be interacting with a lot of vendors. At that time, the question definitely arises that, okay, some vendors have come with some piece of software and they tell you, okay, it's open source software. And believing them, you buy, and then later on, you get into a soup, okay, in a problem. The problem would be because in open source software, though the source code is open, it's for you to view, review, and all feedback you can give, but they may forbid you to modify it. Everybody gets it?
Yeah.
Okay.
Yes.
So open source software, when somebody says, you have to really get into the roots of it and ask him that what exactly, when you say open source, is the license, which license you are going to give, whether it is going to be GNU GPL or open source license itself, or it is going to be BSD, MIT, Apache, or whatsoever. Okay. The real gist is basically that tomorrow, if you have that software coming into your organization, buys it and starts using it, and you want to modify a certain part of it, then you have to take the permissions of the developers or that particular company, though they have released the software called as open source, but you are forbidden to modify it without their permission. It could be a possibility. But when you purely talk about GNU GPL, you have no such restriction. Here we are totally talking about freedom, total freedom. If I have some piece of software and I release it under GNU GPL license, the person who I gave the software has also all these 4 freedoms as you have. So I am not doing the vendor lock-in. Like Microsoft does a lot of vendor lock-in with the different organizations. So they make them dependent on total Microsoft, that you use my piece of software only. You are not supposed to, you have to buy out licenses. You have to have maybe, no modification. You have to come to support and service towards us only. You can't go anywhere else. Okay. So if you buy Windows, you have to be totally dependent on Microsoft for support. So a lot of companies do that kind of stuff where they are not giving you any kind of freedom, and that we call as vendor lock-in. So you are locked in with the vendor where you have no freedom of such kind, like here in the 4 freedoms which we talked about. So you have to totally depend on them to, so they could basically tomorrow manipulate you, twist you to, use the software upgrades. Possibly they will be enforcing you, coerce you to upgrade, like Microsoft does many times. In such scenarios, you will see they stopped supporting Windows XP. Okay, because their other piece of operating system like Windows 7, Vista, and all these things were not selling out. People were happy with Windows XP. So they killed that product because people would otherwise won't go for the upgrade. Similarly for MS Office or other, different piece of software they keep on releasing. So they make people dependent. So vendor lock-in is like dependency on some vendors to, always have the support. So they mint money. Like we already know, Bill Gates was one of the richest person in the world because of this reason only, manipulations, controlling. Whereas free software is giving you the total freedom, but wherever freedom comes, then there comes the responsibility too. So responsibility of managing, maintaining the freedom with whatever the knowledge you have. So it becomes a more techy kind, though. Okay, the Linux is more technical. People, it's really difficult to learn. That is, the newbies who come into the field have a lot of problem understanding what the hell is going on inside the system. I don't understand a lot of commands, command line interface is there, no graphical interface, or if it is having a graphical interface, but we always work on CLI. So the total difference, it's a 180-degree shift in the thought process, which you have to start working with when you get into the free software domain or open source domain. Now, 95%, I should say, or 90 to 95% of the softwares usually are called as open source, but if you check the license, they are GNU GPL. Okay. Now, going forward, I talked about BSD licenses also. I talked about MIT and what you can say, Apache license. Now, anyone from your networking background team have worked with Juniper firewalls? Anyone? Juniper products? Has anyone worked? Juniper? No one has worked with Juniper? Okay, so let me give you an instance. Juniper SRX series firewalls are based out of BSD license, free BSD operating system. So they have taken the kernel of the free BSD, modified it and used it. The reason the BSD license, Apache license and MIT license are basically saying, okay, buddy, if you want to share your source code, you're welcome to do it. If you don't want to share it, don't do it. So they are more commercial friendly, business friendly licenses, where if you want to, redistribute, or you want to go ahead with this kind of freedoms like in GNU GPL license, you are welcome to do so. All right. But if you don't want to share, don't share. So if we go for GNU GPL license, what you have is that if Sandeep buys the software from me, okay, or I give him that piece of software, I cannot deny the source code to him. I cannot say, Sandeep, you just take the product, okay, and I'm not going to share the source code, but my software is released under GNU GPL license. That is not what the GNU GPL license says. It says when you go give the freedom to others, that means you have to give the source code also. So I can't deny the source code. In case I deny, Sandeep can sue me for that. Right? So that means in GNU GPL license, there is a restriction to maintain the freedom at any cost. Okay. So here the source code is a mandate, is necessary. You have to give it. But in BSD, MIT, Apache licenses, you don't. You may or may not. In open source, you will give the source code for reviewing, feedback and all, but you may not develop it. May not. I'm stressing the term may. Okay. It may not be, or it may be under GNU GPL license, but called as open source. So the clarity has to be there. So is everyone clear about free software, open source and proprietary?
Yes.
Okay.
Yeah.
The real reason I wanted to have a discussion on this, because many times I talk and many people say, okay, open source means the software doesn't come with license. Okay. So many people are not aware with GNU GPL license and the terms and all. So I just differentiated between all the licenses. So your organization will have a better chance of, working with vendors with more clarity. Okay, so going forward, those who have attended SA1, I would like them to just brief me up all of what all things have been covered. So we'll talk about certain commands, certain areas. How many people have installed Linux? Other than the experienced guys, okay, I want to put the questions to the persons, those who have come from Windows area. Okay, how many from Windows people have tried installing it? Okay, Neeraj has installed. Anybody else? Okay, so let's take experience of Neeraj. Neeraj, which distribution did you install? Neeraj? Hello, Neeraj, can you hear us? Okay, Vinod, are you there?
Yeah, I'm there.
Yeah, okay. So which distribution did you install?
I've installed Ubuntu and also the Raspbian for the.
Okay, any experience with CentOS, Red Hat or Debian or something?
I've installed Red Hat, but I haven't worked on it much.
Okay, that's fine. All right. When you installed, did you create partitions?
Yeah, I did. Yeah.
Okay. How many?
One was the root partition,
Okay.
the slash, and then you create the swap partition.
All right. Okay.
Yeah.
So in all, how many? Three.
Three. Yeah.
Okay.
I directly
All right.
remember.
And which kind of hard disk did you use? Was it SSD or simply spin disk or magnetic, I should say?
I have used SSD.
Okay.
So basically, I'm into home automation. So it's just a hobby that I do. So,
I
I've
got it through
installed.
when you said Raspbian and all, so I got the idea. You must be from
So
home.
I have played around and spent some time installing and setting it up.
Okay. All right. Coming to Guillermo. Guillermo, how's your experience on that? So.
Yeah, on installing Linux.
Yes.
Whew. Well, a lot. I've installed. Jesus, a lot of servers.
Okay. So, for
Starting
example,
with
okay.
previously Slackware, the Red Hat right now is the one that we installed the most. I created Kickstart files to install it over the network. I create partitions when I install it manually on a PC. So
all right. So Guillermo, how many partitions did you create?
Well, it depends. I create one primary for boot. Then I create one for LVM, Logical Volume Manager. And inside it, I create root, I create /tmp, I create /var, I create US or local, depending on what the box is going to do. If I'm going to create a server, if I'm going to create it for a repository or for users specifically, then I balance the size of each of the partitions depending on the use that it's going to have.
All right, wonderful. Now, considering, for example, the traditional ones, what many people use is magnetic disk, that is spin disk. So when I'm creating the partitions, do I have some advantage? Do we have some advantage in creating the partitions? Technical advantage?
Yes, of course. They fill up individually. You can distribute all the parts of the OS, and then it can. They fill up separately. That's the first one. You have specifically a partition, a different file system for each of these parts. You can expand them if necessary. Only the parts that you need to be expanded.
Okay,
That's
great.
some of them.
Okay, cool. So when I start creating partitions, okay, so how the partitions get formed? From outside to inside, if it's a magnetic disk, okay, spin disk, I should say, normal hard disk. So from outside to inside or from inside to outside?
From inside to outside, I think.
Okay, anybody else? Paul? Paul there? Paul Hernandez?
Sorry, I was on mute again. So what is the question again?
Yeah, question is, when we create partitions, so do we have from partitions getting created from the magnetic disk, I mean to say spin disk, from inside to outside or from outside to inside?
I'm assuming that you're talking about the physical condition on the hard drive, right?
Yes.
And that I don't know. To be honest, I don't know.
Right. Okay.
I will assume that it's the other way around, from the outside to the inside of the spinning disk, but it's just a guess.
Yeah, it's from outside to inside.
From outside to inside.
Yeah. So when you create a, for example, slash partition or a swap partition, generally, if you see traditional, they would always ask you to create the swap partition first because it will be created outside on the outskirts. Now,
Mhm.
why like that?
Is
You know,
that, yeah, I think that kind of, I would think that is a similar thing that the audio, the older audio disc used to do, right? So you start from the outside of the disc, and as the disc is spinning and creating the music and the sound, is going to the inner part of the
Yeah.
audio disc.
Yeah.
okay, okay. So the main reason is something called as angular velocity or angular momentum. So here we get the physics coming in. Okay, if you see the velocity, angular velocity close to the spindle, that is center of the hard disk, is going to be less as compared to what it is going to be outside. So the data accessibility will be at the higher speeds at the outskirts rather than the inside. So
Yeah.
more closer your data is towards the spindle, that is closer to the center of the hard disk, it's going to be fetched more slowly. So that is why, like for example, we have EMC SAN, storage people, right? Who was from storage? Someone in the team has worked with storage, right? Who was it?
I think it was Andre. Probably left for some meeting or.
Okay, so he would be more having the idea that SAN disks basically when they create, they leave out the inner part, at least they leave out that it cannot be writable, so they deny all the writing, and the maximum writing is done on only the outskirts of it. So because of this reason, that it is due to the angular velocity momentum, which is at the higher on the outside area. So great. So we know about partitions, the technical advantages. So more the number of partitions when we go for that. Okay. Now, when we talk about Unix system, what are the things coming to our mind? Can everybody see my screen?
Yes.
Yes.
Okay. So here I am highlighting certain facts of Unix, Linux being a multi-user and multitasking system. So those who are from ancient era of Unix, they would come to know that these are called as dumb terminals, and there was a central system on which all the processing used to happen. So multiple people running their own tasks and system multitasking between all those tasks. Okay, so Unix basically had the concept coming before the development of the operating system. The whole thing started with the project called Multics in going back to around 1961-62, with GE, General Electric, and Bell Labs coming together to create something like this. Okay, but our hardware wasn't there. The thing what we see today wasn't available. So the main core which you need to really understand on a Unix system is that it's a hardcore, a very powerful multi-user multitasking system design. Unix design is in this format. If you see this onion diagram, what we call it. Okay. So are you all looking at the diagram here? You have a central hardware, then there is a Linux kernel, I can call it. Then there is something called system call interface. Anybody any idea on system calls?
They are the actions that the kernel executes, I think.
Okay. System calls. So if I do, for example, on my terminal.
Interruptions.
Are you all able to see my terminal?
Yes.
Yes.
So I have done man syscalls. Okay. So man page of the system calls. So it will list basically all the kernels, and you see down below the system call name and everything. Okay. So lot of system calls. Round about you can say around current kernel is 5.3, so not more than 450 system calls. Okay. Now, as you see, system calls basically like you have read, write, open, close, and all. For processes, you have fork, wait, and there are many others like this. They allow the interaction from the user level till the kernel level. So system call is basically an intermediary who sits in between to coordinate the activities from the user level applications, user land applications to the kernel. Okay. In Unix kind of systems, there is a clear line drawn between the user land applications and system level. Okay. So there always, when you have Unix system, there will be one user level and one system level. System level is basically where all your kernel and everything runs. Okay. And user level where all applications run. So user level applications like maybe Google Chrome or Firefox or GUI, graphical user interface, all these basically are going to talk to the kernel via system calls only possible. That's it. Okay, so we have given roundabout, I'm giving the approximate 450 system calls to interact with the kernel. Okay, now imagine Windows doing it. Windows is having roundabout more than 1 lakh system calls to interact with. So it becomes more problematic approach, because some system calls, if they are not designed or written properly, can cause system bugs. So always we have a lot of bugs coming in over there, inflexibility, instability kind of things coming in Windows kind of thing. That is why you must see now Microsoft is adopting Linux kernel kind of approach, where they will be underlying. Currently it is working with a microkernel kind of architecture. Linux is using monolithic modular kernel architecture. And if you also note that Mac OS from Apple, right, it is again based out of BSD, Darwin. So they have the roots of their operating system, Mac OS, in Unix world. So you will find stability coming off from there because of the design of Unix in such a way that you have been given very restricted number of system calls to interact with the kernel. And there is a line drawn between user level and kernel level. So in any application, if any application creates a problem, immediately there is an intervention by the kernel. You will have a segmentation fault or core dump caused, because kernel will immediately terminate that application, the process basically. So it keeps the system very stable. So it doesn't allow any application to take over the system. Rather, kernel is taking over all the system. So it controls everything. So it's not the other way around, like in microkernel architecture. You have a very minimal kernel, and you have all process management, memory management, IO device management, networking, all acting as a different modules. And in monolithic module, we have everything inbuilt coming in. So system call has got a very profound relevance over here. Then we have shells coming in at the upper layer. You see shell, right? Like now in Linux we have bash, BASH. Bash basically stands for anyone? What is BASH standing for? Any full form?
It's Bourne shell.
There are
Born
two, basically.
again shell.
Yes, born again shell. Okay, so it's a kind of update on the Bourne shell, which earlier Solaris and HPUX by default had. So it is this bash shell is more advanced with tab completion kind of things, which you must have done in the first version of your series of last week sessions. So bash has got a lot of cool features, and other shells are like C shell, more attuned towards C like features. This is Bourne shell, SH. And then you have one Korn shell. Steve Korn had written it, KSH. So you see so many variants of the shells which have come up because of the Unix variants coming into the market. Okay, if you go by the history of Unix, you will see Unix word is also copyrighted. All right, so that means you will never find any company or any organization using the word Unix to name their operating system what they have designed or made. Okay, the reason is they will make it like sound like Unix, like Linux is Linux, UX, HPUX, AIX, IRIX, but no one can call it as Unix because Open Group has copyrighted Unix word as, you know, no one can use it. It's copyrighted. So you will never find any operating system named as Unix. You will find Unix variants like AIX is a variant, HPUX is a variant, IRIX is a variant, all this different ones. So all the people, different people came up with different kinds of kernels and shells, I mean to say. And then above shell is also called as a, what you can say, command interpreter. Okay, shell is also termed as command interpreter, where it basically says, okay, whatever the command you are typing, like ls command you have typed, okay, I interpret it and produce the output. Okay, so it understands the command and gets you the output produced that way. And then above that, X Windows system, we call it. X Windows basically in Linux refers to the graphical user interface when we call it. Underlying it's Xorg application. Earlier it was X386. So Xorg is currently based on for designing the client server architecture of X Windows. So unlike in normal Microsoft Windows, what you have a graphical interface, which is not client server architecture. Here we have X Windows totally based out of client server architecture, and totally this from here system call, where my mouse pointer is, till the outskirts, all the part is in user level part. Okay, down below system call and kernel are coming under system level. Okay, including the hardware, of course. So that is a clear line drawn, as I said. So this is a conceptual architecture of Unix systems. Anybody has any questions on this? Please feel free, don't hesitate to ask. Any clarity you want on this? Any questions, anyone?
No, it's clear.
Okay, great, thanks. So let me come. So very first point, multi-user multitasking. Second aspect of Unix is all of Unix is case sensitive. So like we humans can differentiate between uppercase, lowercase and all, Unix systems are also the same. So all commands are in small case, though options can be in upper or lower cases in Linux. That is gone beyond control of everybody nowadays. But Unix was always supposed to be terse, very short, very precise and short. Okay, so all of Unix is case sensitive. All commands are in case small letters, and it can differentiate between uppercase and lower cases. Unlike Windows, compared to Windows, Windows is in case sensitive. Now, this is again a very crucial point. It does not bother about file name or file extensions. So while working with Linux thus far, or any Unix variant, you must have seen ls command is not like ls.exe or cat.exe. It's simply cat, ls, grep, not grep.exe. So Unix systems don't care what the name is or what the file name is. They don't worry about the extensions. It's the total functionality of the command which is more important than the name of the file or file name. You keep the name of the file whatever you want, the functionality doesn't change. Okay, one of the very important points which differentiates it from Windows. Okay, now fourth, everything is a file or a process. But obvious, in every operating system you have files or the processes. Process is something which is a running program, and file is where you store your data. But when I say everything is a file, can anyone tell me why do I say everything? Especially applying to Unix, we always have this coming in. Can anyone tell me everything includes What all things?
Including the folders.
All right, okay. Anybody else? Okay, now when I say everything, it includes the hardware.
Yeah, even the devices.
Yeah, so you have your hard disk, you have your USB pen drives or keyboard, mice, whatever you talk about is considered as a file. Okay, so that means Unix has a particular way of looking at the things, that okay, my files, what kind of operations do I do with files? I open the file, read or write into the file, close. Same I do with the hard disk. I open the location, read or write to the location, close. From DVD writers, I can do reading or writing into the DVD. Keyboard is only the input device where I can only read from. Right, pen drives I can read and write, considered as a serial device but used as a block device like your hard disk. Okay, so Unix, the application programming interface of Unix is basically saying, for me, since I have to just operate on the devices using this API, so whether it is a hard disk or a DVD writer or whether it's a normal file or a folder, I work the same way. There is no difference for me on this aspect because I have to open, read or write or close. That is what I do with everything. So for me, everything is same. So from API point of view perspective, everything from Unix point of view, I should say, is a file for it. Okay, because file is the simplest abstraction what we have to do the operations with. Similarly, if you look at a folder or a directory, we call it, you have to open up the directory, read or write into the directory. So you might be creating some files or some subfolders within the folder or the directory. So it is again a reading writing operation. So that's cool. So folders are also file for me, right? As we'll see in file permissions, or you might have already seen in the first session. So everything in Unix is supposed to be considered as a file in regards to hardware or software devices. And if something is not a file or a process or a hardware, then it's going to be called as a process, which is going to be something running within the system. And then finally we have inter-process communication, IPC, the most distinguishing point of Unix, inter-process communication. So you must have seen some pipe commands in the last session, ls-l pipe less, ls-l pipe more for viewing the paging output, or you might be doing cat xyz pipe grep filter out something. So we use a lot of pipes, that is inter-process communication we call it. So one process producing it output goes as an output and acts as an input to the process 2. It does the further processing and then it might produce some output which goes as a to third process. So you can have n number of things. So Unix works like a team, so ls command is a team member, grep is team member, cat is team member. So you can combine all of this together to get the expected result. Unix becomes difficult for people to understand for this reason only. Okay, what commands to combine together? So Dennis Ritchie, the creator of Unix systems, has said one thing, that Unix is a system which will be useful or more usable to the people, those who are more creative and imaginative. Okay, so those who have creativity kind of things or imagination, they can use this system very well. So it was kind of because you have to think of the problem solving first and then use the relevant commands to sort out, okay, to solve that problem. So these are the 5 points which I usually talk about in my sessions to make what Unix is all about, what is Linux is all about. Okay, any questions on this point? Anyone? Any doubts or questions? Anyone, please come, please tell me. These are really helpful points. If you understand this very well, Unix is yours. You will be belonging to the community of Unix world, and your efficiency increases a lot.
Now it's clear.
Okay, so this is what Dennis Ritchie had coined. Unix is a simple, it just takes a genius to understand its simplicity. A very much famous quote of this guy who gave us Unix. Okay, so going forward, we have a shell prompt coming in here. Okay, that is the thing. So Windows people, those who are from Windows background, they must be seeing C prompt or CMD after they type, they get C prompt. Here we have shell prompt coming in. So how many types of users do we have in Unix, in Linux, I should say now? Anybody? How many types of users?
Two.
Okay. Anybody else? Everyone agrees with two?
Yes, system user.
Okay, I will say three. Okay, one is the root user, who is the super user, super administrator, I can say. Then there are regular users or normal users, those who don't have any privilege, and then system users who are basically for running applications like my web server or my MySQL database or Oracle database, the users just which allow for applications to run inside them, but no one will ever log in with that username. So they are called as usually for just running applications, so system accounts. So three types of users. Okay.
So, but we can combine this root as well as system users in one. So that's why I told us to.
Usually we avoid running any applications under root user. Okay, root user has only got the privilege of starting the application. Then application will do the context switch and switch itself into some normal user. So there are actually two categories, as someone rightly said, two categories. One I should say as super user, whose UID, GID will always be root 0, and rest all will be from 1 to how many? So how many users can Linux system have? Second question to y'all. How many users can there be in a Linux system? Anyone? Please guess.
An infinite
One.
number?
Of course, infinity, okay, does not exist. So I won't buy that answer. I
As
need a
many
number.
as a number, as many as you want.
All right, but what could be the number? All right, so let me give the number. Everybody can see that? Visible to everyone?
Yes.
2 raised to 32, that is 4 billion users. Right? So Linux systems, if you keep on adding the users into the system, it can go up to this many users. 2 raised to 32, which comes to around 4 billion something. Okay, so it has got really immense powerful system. Coming to the processes, so we have 2 raised to 15 or 2 raised to 16, and Linux kernel has the support of up to these many processes. So normal default, when you have a Linux system installed, you will have the maximum support of 32,768 processes, PIDs, I should say, process IDs. then 2 raised to 16 you can tune up, or Linux kernel support is up to 2 raised to 20. When we fine tune the Linux or Red Hat Enterprise Linux after, I mean to say before putting it into the production systems, any distribution, I usually set it to this limit, which is the kernel Linux kernel support limit. Okay, so you see quite a powerful system over here.
Would that number change if we are talking about a 32-bit platforms or a 64-bit platform?
Yeah, definitely it will go on increasing. If we are talking about, the main thing is the number of bits used for creating user IDs.
Mm-hmm.
So it is used as 32. So 32 bits are basically for user IDs. So that's why we have this limit. So if we start using 64-bit for that, then we'll have the more
a bigger number
scale coming in. Yeah. Okay, so logging out of the system is done through this one, log out, control D, exit and all. Okay, so shutting down the system, this was one way. We call it 3-finger salute or a Vulcan pinch. So you must have seen Star Trek, right? Have you all seen Star Trek? It usually is available on Netflix, one of the costliest serial of its time. Lot of inspiration in today's mobile and materialization, like transportation. So this is really fantastic. So Mr. Spock, this guy is Mr. Spock, used to give Vulcan pinch. So generally rebooting the system, we do pressing Control Alt Delete. So you use 3 keys, index, finger, and other 2 keys for setting up that. This is what is being shown, and the system goes. The person basically is kind of gone into unconscious state. So here, when you're using Control Alt Delete, system is going to go for a reboot. So that is like getting it to be becoming unconscious. All right. Okay. So Control Alt Delete. So usually system administrators will disable this on the production systems. So it should not work while the system gets into production. Okay, so shutdown -S now through graphical interface, though we have right hand menu, but I just wanted to highlight on the command line. So just going a quick brush up on what we did. Hash is basically the prompt for super user. So we do shutdown -H now. So Unix has a particular way of giving commands. Okay, shut down the command, options, and then arguments. So we always call it as command, options. Options always begin with the minus, dash, or whatever you call it here. And then finally it will be followed with some or the other arguments. So command, options, and argument is always the format of the commands. So no longer any confusion anybody should have on this. So -H option means over here is to halt. Okay, so how do we see? So assuming we want to check out, so we'll go for man page. So man shutdown, and check out -H option, scroll down here, and we see -H being explained here. So Unix is basically your, I mean to say man page is your benchmark for understanding that how comfortable you have become with Unix or Linux. Okay, if you aren't able to refer the man page and construct the commands, then it is no go. Okay, then it's not good. So you, after going through the man pages, try to construct the commands and you are able to work out, that's cool. Okay, and every time we Google it out and try to get the ready-made solutions, copy paste the commands, get the job done, that's a no-go. Okay, so depend on the man pages, and it's really cool. Now can someone tell me how many sections does man pages have? Anyone? How do we see the sections? So we'll be doing man and man. And if we scroll down, here you have. So these are the sections of the man pages. You don't need to remember them. Okay, you don't need to remember them all because when you talk about, like, for example, man shutdown, you have the section number being shown here. It's visible to everyone?
Yes.
Okay, so this is the section number which it will refer to, section 8. So if I want to ever check, so I do man and see section 8 is usually for super user, that is system administrative commands. So any command which is coming under section 8 will be for root users. If it is section 1 commands, it's usually shell commands or executable programs. Like, for example, if I do man ls command, so ls command falls under section 1. Right, so here we have different sections. Not all the sections you need to, like man pass wd, it's coming under section 1. So a lot of options over there. And there's one command in Unix, I should say. Let me open up another terminal. This is my Linux Mint system. Okay, so here man pass wd, if I do scroll down, here you see pass wd 5 being shown. But if you look at this pass wd, this is 1. Okay, now this parenthesis or in round brackets the number, it's basically talking about the man page for this particular command to be used. That means section 5. Okay, so how do I open up section 5? Because when I do man pass wd, it is opening up section 1. But if I want to open up section 5, so I have to give it this way. So man, the section number of the command and the command itself, so which should open up the relevant section for y'all. So here it is. All right, so let me just check up whether the labs are ready. Just a second. Oh, I think there is some problem with the labs. Okay, everyone. Hello. Hello, everyone's online. Yeah,
Yes,
I
we're
think
here.
there are some issues with the lab. Some storage issues have come up, so it's down. So what I think we need to do is, I wanted to start with your hands-on on that. Unfortunately, we'll have to wait for them to come up, and they are not sure when it's going to happen. So let's do one thing, since they are not confirming, so I don't want to go for much of the theory what we have so far just discussed. Tomorrow let's start with all the installation configurations. Okay, so let's pause the session over here, and I'll also get the team at the back end to try to fix up the issue ASAP, so that tomorrow we have the practical sessions begin. I wanted to begin today, but unfortunately I just checked with them right now, so they have a problem and it's not yet solved. So I'll take a break here. Okay, and we'll continue tomorrow 7 o'clock IST, Indian Standard Time, and we'll start with the installation of Red Hat Enterprise Linux 8. So I'll be having the ISO images on the storage, I mean to say uploaded onto the system. So you will be installing Red Hat Enterprise Linux with partitioning, okay, without partitioning, and certain other configuration parameters. Okay, so for those who haven't done it, they will also get the chance. Those who have already done it, they will also have the taste of mine. Okay, so let's take a pause and break over here, and let's meet up tomorrow. Should be fine.
Yeah, sure.
Okay, so thank you so much for joining me, and unfortunately the labs are down, so let's begin tomorrow. Thanks everybody. Thanks so much.
Okay. Goodbye.
Bye. Bye. Yes, you will get the recording. Don't worry.